we are going to discuss about RC and RLC circuits. Now considering RC circuit. In case of RC circuit, we are having only resistor and capacitor. This is resistor, this is capacitor. The applied voltage is Vt. Due to this Vt, the current flowing is It. Vt is nothing but sinusoidal function Vm sin omega t. It is the current Im sin omega t plus minus theta. Because it is capacitor, then it will be plus. Because current will lead the voltage by an angle of theta. Though the voltage across this resistor is VR and the voltage across the capacitor is VC, because of the combined effect of these two, we can say circuit is neither purely resistive nor purely capacitive, and hence the angle between for current and voltage lies between 0 and 2 pi by 2. Because this is a capacitive circuit, the voltage will lags the current by an angle of theta, and that angle theta lies between 0 to pi by 2. Now considering the waveform, in this case let me consider this is the voltage waveform. Now this is the current waveform. The voltage waveform is starting from 0, taking from the reference. The current waveform will be starting after an angle, uh, because current leads the voltage, and hence the current waveform will be starting before this reference, and hence by an angle of theta. This angle varies from here to here as theta lies between 0 and pi by 2, and hence the current leads the voltage by an angle of theta, or in other words we can say voltage lags the current by an angle of theta. Now at this instant there is this is voltage, this is current. Considering the product of current and voltage, it will be both are positive, then power will be positive. For this instant, this is power. Now for this instant, after this instant, this is the voltage is positive, whereas current becomes negative. The resultant power, this is P, will be negative. In this case, instantaneous value of P, and hence we can say in case of capacitive circuit, the comparing the with it with inductive circuit, this part was this part was negative in case of inductive circuit. Now in this case this part is positive. Now considering these three waveforms, then we can represent this quantity Vr and Vc, I and I in respect to the space and space and time. Then if it is the voltage, because this is a series circuit, R and C are both are connected in series, I is taken along the reference because current is common in both the elements. The voltage drop across resistance is VR, that will be in same phase with the current because of resistive drop. The voltage drop across this capacitor, that will be I into XC, it will be lagging by the current by an angle of 90 degree, considering pure capacitor. Now because the combined effect of these two, for considering these two combined effect of these two, this is the resultant voltage V, that is nothing but applied voltage V, and this is always a RMS value. This is V is equal to I into Z. Here Z is again the combined effect of R and C, the opposition offered due to the resistance and the inductive or capacitive reactances. Now since neither it is a purely resistive nor purely capacitive, then there will be some angle between 0 to pi, let this angle is theta, and from here the voltage and current phasor can be represented along, considering this is reference axis, the voltage in same phase with current, and the current resultant value of current, resultant value of, this is a resistive voltage drop, the resultant value of the voltage V will be lagging the current flowing in the circuit by an angle of theta. Again V is equal to I into Z. Here Z is the opposition offered, the combined effect of resistor and capacitor. From the phasor notation, Z can be represented R minus JXC. See here minus is taken because XC vector is clockwise. This vector is clockwise the reference. Now then multiplying these three vectors by I, then it will be I into Z, it will be I into R, then I will be into C. The I into Z is nothing but V, I into R is nothing but VR, I into C is voltage across the capacitor. And the way we are representing the phase relationship between Z, R and C, similarly we can represent the relationship between V, VR and VC. Now again calculating the power. Power is nothing but the product of current and voltage. Considering instantaneous voltage and instantaneous current. Instantaneous voltage is Vm sin omega t. Instantaneous current is Im sin omega t plus theta. Here plus is taken because current leads the voltage by an angle of theta. In case of inductor it was minus. Now simplifying this function using trigonometric identity, the resultant value will be this. Now to find out the average value over the complete cycle, we are taking the limit from 0 to pi. The duration will be 1 by pi, and integrating this function with respect to d omega t. The resultant value of p will be equals to Vm Im by 2 cos of theta. Since this is 2 of cos omega t, this function will become 0, and then the resultant power will be Vi cos of theta. The same case as it was in inductive circuit. Now, considering another combination of R, L and C, instead of only having R, L or only R, C, now we are considering R, L and C. This is resistor R, this is L, this is C. The applied voltage is again Vt. The current flowing in the circuit is It. The voltage drop across resistance is Vr. The voltage drop across inductor is VL. The voltage drop across capacitor is Vc. The resultant voltage is V into Z, and I is equal to V by Z. And here Z is equal to R plus minus Jx. X is nothing but the combined, because combined effect, X is equal to XL minus XC, or it will be XC minus XL, depending upon XL is greater than XC or XC is greater than XL. If it is, then it will be XL minus XC. If it is, then it will be XC minus XL. If it is then positive, the overall, if this is the case, XL is greater than XC, then sign will be positive. If XC is greater than XL, then sign will be negative. Now here Z will be R plus minus Jx, because X is this plus and minus is not defined. In this state we don't know what is XL is greater than or XC, or XC is greater than XL, and hence we are taking the common notation, that is plus minus. Multiplying both sides by I, this function will be I into Z, is I into Z into I into X, then it will be nothing but V applied voltage. This is nothing but VR, and this is the combined effect of VL minus VC, or VC minus, or VC minus VL. Now X is XC minus XL, or XL minus XC, depending upon this condition. Now this is VR, that is what we have considered. I into my Z is V, I into my R into my VR, I into my X is Vx. Now again the power consumed in the circuit. Power consumed in the circuit again given by the Vt into my It. Vt is Vm sin omega t. It is equal to Im sin omega t plus minus theta, considering sign as plus or minus depending upon XL and XC. Then further simplifying this function, this trigonometrical function, the resultant value will be this. Integrating this function in order to take average power 0 to pi, and taking 1 by pi, and differentiating or integrating and putting the limits, this component will be 0. The resultant value P average will be equals to Vm Im by 2 cos of theta. It can also be written as Vrms Irms cos theta, or simply V into I cos theta. In electrical engineering, if it is mentioned V into I in capital letter, it is understood that quantities are RMS. Now, as the way we consider impedance and power triangle and voltage triangle in case of inductive circuit, RL circuit, similarly we can consider in case of RC circuit, RL and RC circuit. If it is the voltage or voltage vector VR is equal to I into my R along I, then the resultant value of V in case of capacitor, that will be lagging the current by an angle of 90 degree, that will be VC, because we consider the circuit is R and C. The resultant value will be this one. This is V. This is VR. This is VC. This is V. And for this this triangle, if we can divide by an angle, this is by I. This is I into my Z. This is I into my R. This is I into may xc. Similarly, if we can divide all these phasors by I, the resultant triangle will be, this is R only, then this will be XC only, and this resultant will be Z, and this angle is theta. Again, this angle is theta, and here this is nothing but the impedance triangle. This is voltage triangle. Now, for this, using this voltage triangle, if we can multiply this phasor by I, then it will be a power triangle. This is the power triangle. This is P is equal to V into may, this is VR. VR is I into may R. VR into may I, which is equals to I square R. This is Q. Q is equal to VL into may VC into may I, which is equals to I square into may XC, and this is nothing but I into may Z, and this is S is equal to I square Z, or nothing but V into my I. This angle is theta. Then again we can realize R XC. This will be now XC. This is XC. This is cos theta is R by Z. S is equal to V into my I. The unit is V kVA or simply VA, depending upon the magnitude of the quantity. Now, if the circuit is R, L or C, then the impedance triangle can be here this one, or impedance triangle can be as we consider in the RL circuit, because this resultant the impedance triangle depends upon the XL minus XC or XC minus XL. Now again there are three powers: active power, reactive power and apparent power. Active power is VI cos theta, or simply watt, or it is megawatt depending upon the quantity, magnitude of the quantity. It is VAR, volt ampere reactive, and it is then S is equal to V into I, that is volt ampere. The power factor cos of theta is nothing but the power factor, which is given by P by S, or simply R by Z from impedance triangle. Again there we can define power factor in three ways. From the phasor diagram, cos of theta, that is the cosine of angle between current and voltage. Then impedance triangle, that is cos of theta is equal to R by Z. From the power triangle, cos of theta is equal to P by S.